Standard 9th, Subject Science and Technology Part 1, Lesson number 4, Measurement of Matter. An introduction to the scientist Antony Lavoisier in the year between 1743 to 1794. Antony Lavoisier was a French scientist and he was known as father of modern chemistry. Substantial contribution in the fields of chemistry, biology and economics was given by the scientist. He gave the nomenclature of oxygen and hydrogen. He showed that matter combines with oxygen during combustion. He was the first to use accurate weighing techniques to weigh mass of reactants and products in a chemical reaction. He discovered that water is made up of hydrogen and oxygen. He was the first writer of the law of conservation of mass in a chemical reaction. He assigned systematic names to the compounds like sulfuric acid, copper sulfate, copper sulfite, etc. He authored the first book on modern chemistry, Elementary Treatise on Chemistry, in 1789. He studied the elements such as oxygen, hydrogen, nitrogen, phosphorus, mercury, zinc and sulfur. Law of constant proportion. The French scientist J.L. Proust stated the law of constant proportion as the proportion by mass of the constituent elements in the different samples of a compound is fixed. For example, the proportion by mass of hydrogen and oxygen in water is obtained from any source is found to be 1:8. This means that 9 grams of water is formed by the chemical combination of 1 gram hydrogen and 8 gram oxygen. Here, we will try to understand the law of constant proportion. Atomic mass of hydrogen is 1. Atomic mass of oxygen is 16. When water is formed, the chemical equation can be written as 2 molecules of hydrogen reacts with 1 molecule of oxygen and gives rise to 2 molecules of water. Now we shall find out the molecular mass of hydrogen. See, 2 into 2 is 4. 4 into atomic mass of hydrogen is 1. So it is 4. So the molecular mass of hydrogen is 4. Next, oxygen, the molecular mass is 2 into 16. So it is 32. Now when we find the ratio 4 upon 32, we get it is 1:8. This means that 9 grams water is formed by chemical combination of 1 gram hydrogen and 8 grams of oxygen. Similarly, we can study the other example also. The proportion by weight of carbon and oxygen in carbon dioxide is found to be 3:8. We can check this. In 44 grams of carbon dioxide, there is 12 grams of carbon and 32 grams of oxygen. So when we divide 12 by 32, we get the ratio as 3:8. Thus, the proportion by weight of carbon and oxygen is 3:8 in carbon dioxide. Verification of the law of constant proportion. Many compounds can be made by different methods. For example, two samples of the compound copper oxide, that is CuO, were obtained, one by decomposition of copper carbonate, that is CuCO3, and another by decomposition of copper nitrate, that is CuNO3 twice. From each of these samples, a mass of 8 grams of copper oxide was taken, and each was treated independently with hydrogen gas. Both gave 6.4 grams of copper and 1.8 grams of water. The reaction of copper oxide with hydrogen yielded two known substances, namely the compound water and the element copper. It is known that in the compound water H2O, the elements hydrogen and oxygen are in the proportion 1:8 by weight. This means that in 9 grams of water there are 8 grams of the element oxygen. Thus, if 9 grams of water has 8 grams of oxygen, then 1.8 grams of water is having x grams of oxygen. Now we can find out x by cross multiplication. So x is equals to 8 multiplied 1.8 upon 9. When we solve it out, we get 1.6 grams of oxygen. This oxygen has come from 8 grams of copper oxide. Therefore, both samples of copper oxide will have 6.4 grams of copper and 1.6 grams of oxygen. Now, the proportion by weight of copper and oxygen, if we check, we find 6.4 upon 1.6, that is 4:1. Thus, the experiment shows that the proportion by weight of the constituent elements in different samples of a compound is constant. Now, let us see what the expected proportion by weight of the constituent elements of copper oxide would be from its known molecular formula CuO. To find out this, we need to use the known atomic masses of the elements. The atomic mass of copper is 63.5. The atomic mass of oxygen is 16. Therefore, proportion by weight of copper and oxygen, when we calculate 63.5 upon 16, we find it to be 3.968:1. That is 4:1 approximately. Thus, the experimental value of proportion by weight of the constituent elements matched with the expected proportion calculated from the molecular formula. Thus, the law of constant proportion is verified.